Today we're going to become more fluent with function notation. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Not only are we going to be more fluent with function notation, but we're also going to review a lot of the math that we learned in my beginning algebra course. And we're going to start by finding an input of a function if we're given the corresponding output. So this problem says if f of x is equal to 2x minus 3 and f of b is equal to 9, find b. So what it's telling us is we're plugging in some number into the function and we're getting 9, but we want to know what that number is that we're plugging in. So this problem is really easy in terms of the math. What it's telling us is if y is equal to 2x minus 3 and y is 9, then what is x? So that's a really easy problem. What makes it difficult is the function notation. When students read this, they usually get pretty confused because, again, function notation is very confusing. So really most of what we're doing today is going to help us become more fluent with function notation. And we're going to do a lot of problems today that are the same type of problem when it comes to the function notation. And you might think to yourself, well, I don't want to do so many of these problems. I don't need to, but you have to understand that your unconscious mind is going to absorb a lot of information as you become more and more comfortable with this function notation. So I want you to do every problem that I tell you to do. Do every single problem and don't cut any corners. So let's attempt this problem here. We're told that f of x is equal to 2x minus 3. But if that's true, then that means that f of b is equal to 2b minus 3 because we're plugging in b rather than x. Notice that these equations are exactly the same, except we're just plugging in b for our input. So we're also told that f of b is equal to 9. So now I'm going to rewrite this exact same equation, but instead of f of b, I'm going to write 9. So what this problem is telling us is if we plug in b into our function as the input, then the output is going to be 9. And we're trying to figure out the value that we plugged in to get 9. So we'll just add 3 to both sides and divide both sides by 2, and we see that b is equal to 6. So the math is very easy on that particular problem. Again, it's the function notation that creates a lot of anxiety in students. So let's try another problem. Let's read it first. If f of x is equal to 4 minus x over 9 and f of c is equal to 10, find c. So c is just a constant, but we don't know what it is, so we name it with a letter. So we're told that f of x is equal to 4 minus x over 9. If that's true, then that means that f of c is equal to 4 minus c over 9. That's the way it is with all functions. If you change the input, then the output is going to change. But we're told that f of c is 10. So I'm going to rewrite the same equation, but instead of f of c, I'm going to write 10. So it's the same exact equation, but we know that f of c is 10. We're told that information up here. So now we just have to solve for c and find the value that we plugged in to get 10 as our output. So if our input is c, our output is 10. Subtract 4 from both sides. multiply both sides by -9, and our answer is -54. So let's do a couple more of these types of problems. So if f of x is equal to 7 minus 5x and f of m is equal to -2, find m. So we know that f of x is equal to 7 minus 5x. And if that's true, then f of m is equal to 7 minus 5m. But we're also told that f of m is equal to -2. That means when you plug in m into the function, you get -2 for the output. So I rewrote the same equation down here. I just changed f of m to -2. So now we subtract 7 from both sides and divide both sides by -5, and we get -9/5. So let's try one more of these before you try one on your own. We're told that f of x is equal to x over 2. But if that's true, then f of a is equal to a over 2. But we're told that f of a is equal to 1. We're told that up here. So then we can just solve that equation, and we see that a is equal to 2. So very easy. Okay. So I want you to try number 5. You can use numbers 1 through 4 to help you. And when you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to 4x plus 3. But if that's true, then f of k is equal to 4k plus 3. Now, you're probably wondering, do I have to write this? Can't I go straight to this green step here? And the answer is yes. You don't have to write the blue step if you don't want to. You don't have to write this first step. Now, f of k, we're told, is -8, so I'm just going to rewrite that same equation, except I'm going to replace f of k with -8. When we plug in k as our input, our output is -8. So now I'm going to solve for k, and you don't really have to show the math because this is a simple problem. And we get -11 over 4. So if you got that right, excellent. Go ahead and try number 6, and when you come back, we'll do it together. Okay, we're back. Like I said, you don't have to do this first step, but I'm just doing this for your benefit so you can see. We know that f of x is 3 plus x over 5. So f of p would be 3 plus p over 5. We also know that f of p is 4. So we're just going to rewrite the same equation and replace f of p with 4. Then we're going to subtract 3 from both sides. And multiply both sides by 5. And we see that p has to be equal to 5. So if you plug in an input and get 4, then that input must be 5. So that's the problem that we're answering. So if you got that right, excellent. Try number 7. When you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to -3x plus 10. And so if that's true, then f of r is equal to -3r plus 10. And we're told that if you plug in r for your input, then your output is 25. So if we solve for r in that equation, we get negative 5. You don't have to show all the steps if you don't want to. So if you got that right, excellent. Try number 8. When you come back, we'll do it together. Alright, we're back. So we know that f of x is equal to 6 minus x over 4. And if that's true, then f of v has to be 6 minus v over 4. But we're also told that f of v is negative 1. So I'm just rewriting this same equation down here, except I'm replacing f of v with negative 1. Then I'm going to subtract 6 from both sides. And I'm going to multiply both sides by negative 4. And we get 28. Alright, so if you got that right, excellent. Okay, so let's do some more problems. Now, you might be thinking that I don't need to do any more of these problems. I get the idea. But, again, your unconscious mind is taking in a lot of information here as you become more and more comfortable with this notation. So I want you to do a lot of these problems, even if you don't want to do these problems. Let's try another one. If f of x is equal to x squared plus 9x plus 10, and f of b is equal to negative 4, find b. So it's the same type of problem, but there's different math occurring here. So we know that f of x is equal to that expression up there. But if that's true, then that means that f of b has to be equal to b squared plus 9b plus 10. And f of b is negative 4. So I'm just rewriting the same exact equation, and I'm just replacing f of b with negative 4. So what this tells us is if your input is b, then your output is negative 4. But at this point, we have a problem. We can't solve this equation unless we understand what type of equation it is. This is a special type of equation. See if you can remember what these equations are called. It starts with a Q. What type of equation is this? It starts with a Q. Well, that's a quadratic equation. Now, another thing that we need to understand is that we cannot solve a quadratic equation unless we put it in standard form. It's not in standard form. In order for it to be in standard form, we have to have 0 on one side of the equation. So I have to add 4 to both sides of the equation. And we have to make sure that this term comes first, this second, and this third. So if these terms are rearranged in any way, we can't use our methods to solve the equation. So now that we've recognized the equation as a quadratic and we've put it in standard form, we need to use the methods, the special methods that we learned to solve this. So remember, to solve a quadratic equation, we can factor, but if factoring doesn't work, we can use the quadratic equation. Now we could try graphing the quadratic equation, but that's not really practical. And we also could try to complete the square, which is the method that we use to derive the quadratic formula, but again, that's not practical either because that's a much longer method. So we want to try factoring if we can, and if that doesn't work, we'll use the quadratic formula. So there's only really 2 methods that are practical for solving a quadratic equation, even though there's technically more than 2 methods. So we want to ask, what are two numbers such that when you multiply them, you get 14, and if you add them up, you get 9? And the answer is 2 and 7. So what this expression tells us is that b can be -7 or -2. So we changed the form of this expression to this form here, and that allowed us to see the answers. Okay, so let's try number 10. So we know that f of x is equal to x squared minus 3x minus 26. But if that's true, that means f of c is equal to c squared minus 3c minus 26. And we also know that f of c is 2, so when you plug in c into the function, you get 2 for the output. So if the input is c, then the output is 2. But this is a quadratic equation. We can't solve it unless we put it in standard form, so I'm going to subtract 2 from each side of the equation, for both sides of the equation. And now we simply ask, what are two numbers such that when you multiply them you get -28, and when you add them up you get -3? So that's going to be -7 and +4. So by changing the expression to that form, we see the solutions just by looking at the equation. So I want you to try number 11, and when you come back we'll do it together. Okay, we're back. So we know that f of x is equal to x squared plus 3x minus 1. And we know that if that's true, that f of k must be k squared plus 3k minus 1. And we're told that f of k is 9. So now we have to just solve this equation. It's a quadratic. We can't solve it without putting it in standard form. So I'm going to subtract 9 from both sides of the equation, and then we're going to use factorization to help us solve it. So what two numbers multiply to -10 and add up to 3? That's going to be 5 and -2. And so k is equal to -5, and k is equal to 2. Alright, so if you got that right, excellent. Try number 12. When you come back, we'll do it together. Okay, we're back. So we're told that f of x is equal to x squared minus 2x minus 6. But if that's true, then that means that f of m must be equal to m squared minus 2m minus 6. And we're also told that f of m is equal to -7. So I'm just going to rewrite that same equation and replace f of m with -7. So if the input is m, then the output is -7. So this is a quadratic equation. I can't solve it unless I put everything on one side. We need to put it in standard form. And then I have to use special methods to solve the quadratic. What two numbers can we multiply to get 1? And when we add them, we get -2. What are two numbers such that when you multiply them, you get 1, and if you add them, you get -2? Well, that's -1 and -1. So for this equation, there was actually only one solution. You don't have to write m equals 1 twice, but that's just one way to do it. You'll see that in textbooks sometimes. So if you got that right, excellent. Okay, let's go to some more problems. So in this problem, we're told that f of x is 10x squared plus 17x. If that's true, then that means that f of d is equal to 10d squared plus 17d. But we're told that f of d is equal to negative 3. So I'm just going to rewrite f of d as negative 3. So I'm copying the same exact equation, just replacing f of d with negative 3. And this is a quadratic equation, so I have to put it in standard form in order to be able to solve it. So now it's in standard form. And be aware there's a coefficient here, so that's going to make this a little bit more difficult to factor. I have to first ask, what are two numbers that such that when you multiply them you get 10? Well, I'm going to start with 2 and 5. I don't know if those are going to be the numbers we're looking for. We could also say 1 and 10. And what are two numbers that multiply to 3? Well, I'm going to choose 3 and 1. 3 times 1 is 3. But we have to check this factorization. We don't know if that factorization is correct. So to check it, we're going to use FOIL. So we're going to multiply these two binomials together to see if we get the original expression, or the previous expression. So the first terms, if we multiply those, we get 10d squared. Outside terms, multiply those, we get 2d. Inside terms, multiply those, and we get 15d. And the last terms, multiply those, and we get 3. And if you simplify this expression, you get 17d. Now, if I had put the 1 over here and the 3 over there, I would have got something different. But that's okay. We could just try again. Try switching the 3 and the 1. So the factorization is correct. So by looking at this expression, I can see what my solutions are going to be. If d is negative 3, that makes one of those factors 0. And if d is negative 1/5, it makes the other factor 0. So that makes the equation work. Okay, I want you to try number 14. When you come back, we'll do it together. Okay, we're back. So we're told that f of x is equal to 7x squared minus 43x minus 30. If that's true, then that means that f of r is equal to 7r squared minus 43r minus 30. But we're also told that if you plug in r, you get negative 36 as the output. So now we have a quadratic equation. I can't solve it unless I put it in standard form. So I'm going to add 36 to both sides. And now our quadratic is in standard form, and we're going to factor. And what two numbers can we multiply to get 7r squared? Well, that's going to be 7r and r. So two numbers that multiply to 7 are 1 and 7. And then what are two numbers that multiply to 6? Now they're going to have to be negative. And the reason I know that is because we have a negative here. When you add the outside term and the inside term in our FOIL acronym, you should get a negative. So that means both numbers have to be negative. So I'm going to try 2 and 3. So we have negative 21 and negative 2r, which is going to be negative 23r if you FOIL. You don't have to do the F term and the L term if you don't want to. You can just do the O and the I term, because we know that they're gonna show us if our factorization is correct. So that doesn't work. So I'm going to change to 6 and 1, and then if we check with FOIL, we see that the factorization works. F of FOIL is 7r squared, O of FOIL is negative 42r, I of FOIL is negative r, and L of FOIL is positive 6. So combine these together, you get negative 43r. This is all review information. So r is going to be 1/7, or r can be 6. Okay, if you got that right, excellent. So let's try number 15. So f of x, we're told, is equal to the following expression. If that's true, then that means that f of k is equal to the same expression with k plugged in instead of x. We're also told that f of k is equal to 1. So I'm going to write the same exact equation, except instead of f of k, I'm going to write 1. So what this means is if you plug in k to the function, you get 1 as your output. So now we have a quadratic equation. I need to put it in standard form before we can solve it, so I'm going to subtract 1 from both sides. But when we subtract 1 from both sides, we see that this 1 goes away. So this is different from the typical quadratic equations that we solve, and a lot of students would get stuck at this point. Some students would put one of these terms on the other side and then divide by k. You don't want to do that, because you'll miss a solution. What we want to do is factor out the GCF, the greatest common factor. So I factored out k, and the reason that works is because if we go backwards using the distribution rule, k times negative 9k is negative 9k squared, and k times 1 is k. So factoring is just the opposite of the distribution property. But typically students don't like that. They don't want to factor things. But in this problem, it's the best method for finding the solution. So now we see what our answers are. K can be 0 or 1/9. So this factor here told us that 0 is a solution, and this factor here told us that 1/9 is a solution. Alright, so I want you to try number 16, and when you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to 2x squared minus 4x minus 4. But if that's true, that means that f of b is equal to 2b squared minus 4b minus 4. And we're told that if we plug in b into the function, our output is negative 4. So I wrote the same equation, but instead of b, or instead of f of b, I wrote negative 4. So we want to put this equation in standard form. If we add 4 to both sides, we see that these green negative 4's just canceled out. So now we're going to factor out a GCF, which is 2b. The GCF is the biggest number that can go into these two terms, the greatest factor that's common to both these terms. 2b times b is 2b squared, and 2b times negative 2 is negative 4b. So that factor tells us that b can be 0, and the other factor tells us that b can be 2. So if you got that right, excellent. I'm going to use a different color for this here. Sorry, my computer's going a little slow. Okay, so let's try some more problems. So in this problem, we're told that f of x is equal to 4x squared minus 5x minus 3. If that's true, then f of m is equal to 4m squared minus 5m minus 3. And we know that f of m is 4. And so now we have a quadratic equation, but we can't solve it unless we put it in standard form. So I'm going to subtract 4 from both sides of the equation. And now our quadratic is in standard form, but the problem is when we try to factor this, we'll find that we can't really do it very easily. So we need to use the quadratic formula. So if you recall, the formula tells us that the solution to any quadratic equation is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So a is 4 and b is negative 5. And c is negative 7. So let's plug in the numbers. So we have a double negative, and then we're going to square a negative. Whenever you square a negative, you have to use parentheses. If you don't use parentheses, then it's going to be wrong. And then a is 4. So we plugged in a is 4, we plugged in c, and we plugged in b. So let's simplify. So we get 5 plus or minus root 25 plus 112 over 8. Negative 4 times 4 is negative 16. Negative 16 times negative 7 is positive 112. So now we have 5 plus or minus the square root of 137 over 8. If we add all these terms here, we get 127. Or 137. So there are two solutions. M can be 5 plus the square root of 137 all over 8, or M can be 5 minus the square root of 137 all over 8. So I want you to try number 18. you're going to have to use the quadratic formula, just like we did in problem 17, so when you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to negative 2x squared plus 7x minus 3. But if that's true, then that means f of p is equal to negative 2p squared plus 7p minus 3. And f of p, we're told, is negative 8. And so this is a quadratic equation. We have to add 8 to both sides of the equation. Now, normally you would want this coefficient to be positive, but because we're going to use the quadratic formula, it doesn't really matter. So now let's use our quadratic formula. So we're going to have we have negative b plus or minus root b squared minus 4 times a times c. You don't have to write the quadratic formula every time you use it. All of that over 2 times a. So I'm going to use the same colors here just so we can know where everything came from. You don't have to use colors if you don't want to. Okay, so p is equal to negative 7 plus or minus the square root of 49 plus 40. Negative 4 times negative 2 is 8, and 8 times 5 is 40. And 2 times negative 2 is negative 4. So now p is equal to negative 7 plus or minus the square root of 89 all over negative 4. Now, you can leave your answer like this if you want, that's okay, but just be aware that in textbooks you're going to see the answer written in a different way. So there's two solutions. There's negative 7 plus root 89 over negative 4, and there's negative 7 minus root 89. Now, if I multiply both sides of this fraction by negative 1, and multiply the denominator, we get positive 4. Multiply the numerator, I'm going to use distribution, and we get 7 minus the square root of 89. So I multiplied both sides of this fraction by negative 1. If I multiply both sides of this fraction by negative 1, then I get 4 in the denominator. Using distribution, I get the following expression. So the two answers are 7 minus root 89 over 4 and 7 plus root 89 over 4. So notice that our plus or minus symbol would be equivalent to this up here, but instead of having negative 7 and negative 4, we have positive 7 and positive 4. So the way you're going to see it written in textbooks is p is equal to positive 7 plus or minus root 89 over positive 4. So you can multiply both sides of this fraction by negative 1. That changes the negative 4 to 4, changes the negative 7 to 7, but the plus or minus it doesn't do anything to, because it's still going to be positive root 89 or negative root 89. So I know that's kind of confusing, but just be aware that when you multiply a plus or minus symbol by a negative, it doesn't change the symbol. Okay, so if you got that right, excellent. So let's try another problem like that. So we're told if f of x is equal to 4 plus x over 3 minus 1 squared over 2, to find to find c if f of c is equal to 6. So it's the same type of problem. Now, if this is true, that means that f of c must be equal to 4 plus c over 3 minus 1 squared over 2. So we're also told f of c is 6. So we're going to plug in 6 for f of c. And now we have an equation with a square. So what we have to do is isolate that square. We have to get it by itself. It's not by itself because these green numbers are next to it. So I'm going to subtract 4 from both sides. Then I'm going to multiply both sides by 2. And at that point, I'm going to square root both sides of the equation, because we can't get to the c unless we square root. Now, you don't have to show the square rooting if you don't want to. I'm just going to show this so you can see what's happening. And one of the most common mistakes that students make, maybe the most common mistake that students make, is they don't write a plus or minus symbol. Whenever you square root both sides of an equation, you need to write a plus or minus symbol on the side opposite the square symbol, the exponent 2. So then we get plus or minus 2 is equal to c over 3 minus 1. So the square root symbol counteracted the exponent 2. So now we have two different scenarios. We have positive 2 is equal to c over 3 minus 1, but we also have negative 2 is equal to c over 3 minus 1. So now if we solve for c in this first equation, we get 9. And if we solve for c in the second equation, we get negative 3. So those are the two answers. So we had to solve an equation with a square. So let's try another one of those problems before you try one on your own. So we're told that f of x is equal to negative 3 times 11v, or 11x, plus 4 squared minus 1. And if that's true, we know that f of v must be the same thing. Except with v plugged in. We're also told that if you plug in v as your input, your output is negative 6. And so now we have an equation with a square. We just have to solve that equation, and in order to do that, we have to isolate the square. So we have to put the blue numbers on the other side of the equation. So I'm going to add 1 to both sides of the equation. And then I'm going to divide both sides by negative 3. And you don't have to show the math if you don't want to, but we're going to square root both sides. When I say you don't have to show the math, I mean you don't have to show the square root symbol. So I square rooted both sides without showing the orange square root symbol. Now here, we have to deal with this irrational denominator. We're not allowed to keep denominators irrational. So we have to use that important principle with square roots and fractions. If we square root a fraction, that's just the same as square rooting the numerator and the denominator and then dividing them. And then what we do is we multiply both sides of the fraction by root 3 to rationalize the denominator. So I'm going to move to a different part of the paper so we have more room. So root 5 times root 3 is root 15, and root 3 times root 3 is root 9, but of course you know that root 9 is just 3, so that's why we did that. There's no more root in the denominator. That's what it means to rationalize the denominator. So we're out of room, but that's okay. So let's go up here, and I'm going to copy that equation. And so we're going to now subtract 4 from both sides. And to isolate v, we only have one more step. We just have to divide both sides by 11. Only problem with that is that we're going to come up with a complex fraction if we do that. So watch what happens. Divide the whole side by 11, and you see that this is a complicated fraction. That's why we call it a complex fraction. Now there's a lot of different ways to simplify this fraction, but the easiest way is to simply multiply both sides of the fraction by 3, because that's the denominator of this fraction here. And it's just going to cancel out the 3. So I'm going to multiply both sides by 3, and we're going to use distribution. First of all, the denominator is going to be 33. 3 times 11 is 33. 3 times negative 4 is negative 12. And 3 times this fraction is just, well, it's just going to cancel out. So it's going to be plus or minus root 15. So there you go. Alright, so some of the other ways to solve that, we could, sorry, that's OneNote, Microsoft's OneNote program, jumping around like that. So we could write this number as a fraction and then combine these two fractions and then use the basic division operation, because this symbol here is division, and then we'd end up dividing the two fractions like so, and change to multiplication, flip the divisor and multiply straight across. But that's not really practical when you get to upper mathematics. It takes too long. Okay, so now it's time for you to try. You can take a picture of number 19 and use number 20 to help you. Attempt number 21. When you come back, we'll do it together. Alright, we're back. So we know that f of x is equal to negative 5x plus 4 squared over 3 minus 8. We also know that Well, if that's true, then f of b has to be negative 5b plus 4 squared over 3 minus 8. And so we know that f of b is equal to negative 5. So we're just going to replace that with negative 5. And now we have an equation with a square. So we have to isolate this square, get it by itself. So I'm going to add 8 to both sides of the equation. And then we're going to multiply both sides of the equation by 3. And then we're going to square root both sides of the equation. And remember, one of the most common mistakes that students make, and possibly the most common mistake students make, is they forget to write a plus or minus symbol when we square root both sides of an equation. So now we have two scenarios. We have 3 is equal to negative 5b plus 4. And we have negative 3 is equal to negative 5b plus 4. Both of those situations need to be analyzed. So let's solve for b in this equation. Subtract 4 from both sides, divide both sides by negative 5, and we see that b is equal to 1/5. We solve for b in this equation, we get 7/5. So if you got those answers, excellent. Okay, so you can take a picture of these problems if you want to, and I want you to try number 22, and when you come back we'll do it together. Alright, we're back. So we're told that f of x is equal to that expression there, but again, you don't have to write what f of x is equal to. And if that's true, then f of r is equal to the same expression, just with r instead of x. But we're told that if you plug in r to the function, you get 15 for the output. And so now we have an equation with a square, and we're just going to isolate this square here by getting these green numbers on the other side of the equation. So I'm going to subtract 10 from both sides, and I'm going to divide both sides by 2. And I'm going to square root both sides of the equation, remembering to write a plus or minus symbol, which is something that's almost a guarantee that students are not going to remember. And so now we have to rationalize the denominators. So remember, that changes to square root 5 over square root 2. And you don't have to show any of this. If you can do it in your head, then really you need to do it in your head. We're then going to multiply both sides of the fraction by root 2, because that's going to get rid of the root symbol in the denominator. It's going to rationalize the denominator. So then we get plus or minus root 10 over root 4, And as you know, the square root of 4 is just 2, and that's why we did that. It's going to get rid of the root in the denominator. So now we have plus or minus the square root of 10 over 2 equals r over 3 plus 6. So now we have to isolate r. So I'm going to subtract 6 from both sides. And then I'm going to multiply both sides by 3, and we get plus or minus 3 square root 10 over 2 minus 18. And so those are the two solutions. So they got that right. Excellent. That was kind of a challenge problem. Okay, so on to number 23. So just some more types of problems here. We know that f of x is equal to 4 times the square root of 3x plus 1. But if that's true, then that means that f of b must be 4 times the square root of 3b plus 1 plus 9. And we know that f of b is 13 because they tell us that. They tell us if you plug in b for the input, then the output is going to be 13. So I just rewrote this same equation down here that I had in blue, except I replaced f of b with 13 because they told us that it's equal to 13. So now we just have to solve this equation, but how do we do that? Well, we isolate the square root just like we isolated the square in the previous problems. So I'm going to subtract 9 from both sides. And then I'm going to divide both sides by 4. Then I'm going to square both sides. You don't have to show the squaring, but for this first problem I'm just going to show it. So we are squaring both sides of the equation. And 1 to the second power is just 1. And the squaring gets rid of the square root symbol. Subtract 1 from both sides of the equation. And b is equal to 0. So there you go. So let's try one more of these before you try one on your own. So we're told that f of x is equal to negative 3 times the square root of x over 2 minus 7, and all that is added to 5. If that's true, then f of c must be equal to the same expression, just with x replaced with c. And we're told that if you plug in c for the input, then the output is negative 6. Remember, f of c represents the output. And we have to make sure that the plus 5 is outside of the square root, or else things can get confusing. Okay, so now we just need to isolate the square root in order to solve the equation. So I'm going to subtract 5 from both sides of the equation. Then I'm going to divide both sides by -3. And then I'm going to square both sides, and we don't have to show the squaring as we did over here. But it would probably be beneficial because now we have a fraction. And 11 times 11 is 121. 3 times 3 is 9. And the square root symbol just goes away. So what this means is you're multiplying 11 thirds by 11 thirds. And when you multiply fractions, you just multiply the numerators and you multiply the denominators to get 9. So that's all stuff that you should know at this stage of your math education. So don't expect your pre-calculus teachers to show you how to do that. They're not going to show you how to do that. They're going to expect you to know how to do that, and if you don't, then it's going to be considered your fault. Or your teacher's fault. Because you should know that by now. So now let's solve for C. So we're going to add 7 to both sides of the equation. And we get 184 over 9 is equal to C over 2. And then we're going to multiply both sides by 2. And 184 over 9 times 2 is 368 over 9. And we can't really reduce that fraction. So there you go. So I want you to take pictures of number 23 and 24, and you're going to use those problems to help you with 25 and 26. So go ahead and try number 25. Remember, you want to isolate the square root, and when you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to that expression in there. And we can't forget this blue negative symbol here. Don't forget that. And if that's true, then f of k has to be equal to the same expression except k instead of x. And we're told that f of k is equal to 1. And we're asked to find k, so we have to isolate the square root. So I'm going to subtract 1 from both sides of the equation. And then I'm going to multiply both sides of the equation by -5. And then I'm going to square both sides of the equation, and you can show that, but you don't really have to. So that gets rid of the square root. 0 times 0 is 0. And then we're going to subtract 3 and divide by 2, and k is equal to -3/2. So if you got that right, excellent. Go ahead and try number 26. And when you come back, we'll do it together. Alright, we're back. So we know that f of x is equal to 2 times the square root of x over 5 minus 4, all that minus 10. And if that's true, then of course we know that f of b is equal to the same thing, just with b plugged in. And we also know that f of b is equal to -7. And so now we just have to solve the equation. Let's isolate the square root symbol. So I'm going to add 10 to both sides. And then I'm going to divide both sides of the equation by 2. And then we need to square both sides. So when we square that fraction, we're going to get 9/4. Then we need to add 4 to both sides. And we get 25 over 4 is equal to b over 5. Then we're going to multiply both sides by 5, and we get 125 over 4 is equal to b. So if you got that right, excellent. Okay, so now we're going to go to more of these problems. So we know f of x is equal to 1 over x minus 3. And if that's true, then we know that f of b is equal to 1 over b minus 3. And we also know that f of b is 2. So now all we have to do to find b is to solve this equation. But a lot of students will have trouble with this type of equation. And there's many different ways to solve this. One way is to write 2 as 2 over 1, and then just flip both sides of the equation. So we can flip 2 over 1 to 1 over 2, and 1 over b minus 3 to b minus 3 over 1. This is a possible method. And then we have 1/2 is equal to b minus 3. This equation is much simpler than this equation because the variable is not in a denominator. So this is based on the principle that if a is equal to b, then 1 over a is equal to 1 over b. So that's one way to do it. Another way to do it is to multiply both sides of the equation by b minus 3, because that's going to get rid of the fraction. Then we have 2b minus 6 is equal to 1. These are going to cancel out. But students tend to prefer a different method. They like changing 2 to 2 over 1, as we did in the first method. And then they like changing that fraction by using the fundamental principle of fractions. So we have 2b minus 6 over b minus 3 is equal to 1 over b minus 3, and then we have two fractions that are equal to each other and the denominators are the same, so the numerators must be the same, and we're left with 2b minus 6 because we can simply get rid of the yellow denominator. So I'm not exactly sure why students prefer this method, but they like that method, but the problem with it is it just takes too long. That's not really practical to solve a problem like that. If you do it in your head, I guess it's fine. But having to write all that stuff down is certainly not the preferred method. So I'm just going to use the second method. And even with the second method, you don't have to write this down. You can actually do this in your head. Now, some students might say, well, wait a second, if you can do this in your head, why don't you do it in your head? Well, because then you wouldn't see any of the work that I'm doing. So I just want you to be aware that you don't have to show this work. The reason I'm showing it is because if I don't show it, then you can't see anything that I'm doing. Now, it's okay to skip some steps, but again, we're reviewing a lot of this material, and so I'm purposely not skipping too many steps. So there we go. Let's try another one of those problems. Here we're told that f of x is equal to 2 over 4x plus 5. If that's true, then f of c is equal to 2 over 4c plus 5, and f of c is equal to 7. We're told that f of c is equal to 7. So now we just have to solve this equation. Now, just to let you know, again, sorry, that's Microsoft throwing us around the page. So you don't have to really show any of the work. You can just multiply both sides by 4c plus 5, and you can get to this point. If you multiply this side by 4c plus 5, it cancels out the denominator. You're left with 2. And multiply this side by 4c plus 5, and you can even skip this step and just use distribution immediately. So going from here to here is really what you would do when you get into upper mathematics courses. So we're going to subtract 35 from both sides of the equation, and then we're going to divide both sides of the equation by 28. Now, your calculus teacher is going to expect you to do this without any help. So if you're having a lot of trouble with this, then that suggests that you haven't completed the assignments that I gave you in this course and the previous courses. So but get a picture of these two problems, and I want you to try number 29. When you come back, we'll do it together. Okay, we're back. So we know that f of x is equal to -1 over x plus 2. But if that's true, then f of m is equal to -1 over m plus 2. And we're told that f of m is equal to -10. And now we just have to solve that equation. So I'm going to multiply both sides by m plus 2. And then solve for m. And we get -19 over 10. So, if you got that right, excellent. Okay, go ahead and try number 30, and when you come back, we'll do it together. Alright, we're back. So we know that f of x is equal to 7 over 8 minus 5x. But if that's true, then that means that f of n is equal to 7 over 8 minus 5n. And we know that f of n is 2, so we just have to solve this equation. multiply both sides by 8 minus 5n, and we get 16 minus 40n is equal to 7, or 16 minus 10m. And subtract 16 from both sides, and we get negative 9, and then divide by negative 10, and we get 9/10. So we got that problem. Good job. Okay, so now we're moving on to something a little different. You may think we didn't really need to do that many problems that are the same type of problem. Well, again, understanding the function notation is something that just takes a lot of practice. And so it may not seem like it, but your unconscious mind is becoming more comfortable with the function notation. And that's why we did so many problems. We also did those problems because, again, we're reviewing a lot of the math that we did in previous courses. So now we're going to find inputs of functions that make equal outputs. Let's do number 31, and you can see what exactly we're talking about. So it says here, if f of x is 3x plus 7 and g of x is negative x plus 1, for what value of x does f of x equal g of x? So we want f of x to equal g of x. And we know that f of x is 3x plus 7, and we know that g of x is negative x plus 1. So instead of g of x, I wrote this, and instead of f of x, I wrote this. So I want to make it very clear. What we did is we took this equation and we rewrote it down here. It's the same equation. The only difference is we replaced g of x with that expression there, and we replaced f of x with this expression. So we want these two values to be equal to each other. And we're asked to find the x value that will make them equal to each other. So all we have to do is solve this equation. If this is true, then what x value makes that true? Well, you just solve the equation, and that determines the answer. So I'm going to add x to both sides of the equation and subtract 7 from both sides of the equation, and then I'm going to divide both sides by 4, and we get negative 3/2, and you're done. So again, all you have to do is solve that equation. You can do that in as many steps as you want to, but at this stage of your math education, you can probably do that mostly in your head. Okay, let's try another one of these. If f of x is equal to 2x plus 1 and h of x is equal to 3x plus 4, for what value of x does f of x equal h of x? Now notice that we're using f, g, and h. Those are the most common letters we use for functions. So we want f of x to be equal to g of x, or excuse me, h of x. We want those to be equal, and so we have to find the x values that make them equal. So I just took this equation and rewrote it down here, but I replaced f of x with 2x plus 1, and I replaced h of x with 3x plus 4. So now I'm going to subtract 2x from both sides, and I'm going to subtract 4 from both sides, and we're done. So x is negative 3. Okay, so let's try this next problem. So it says, if f of x is equal to negative 1/2 x minus 8, and g of x is equal to 2 times x minus 4, find the coordinates of the point where the graphs of these functions intersect. So let's say we graph this function. It might look something like this, and if we graph this function, it would look something like this. So they're linear functions. And it's asking us to find the coordinates of that point where the graphs intersect. So we're looking for an input and an output that work in both of these equations. That's the point of intersection. The x and the y value that works in both equations. So remember, g of x and f of x are the y values. Probably the easiest way to think about this problem is you really have a system of equations like we solved in my beginning algebra course, and also we did this in my intermediate algebra course. And you're asked to find the x and y values that work in both equations. So the easiest way to do it is just to take one of these equations. I'll take the first equation and rewrite it. Rewrite the exact same equation, but instead of y, we can plug in what the second equation tells us y is equal to. So 2 times x minus 4. So we're setting the y values equal to each other. But in terms of the function notation, what that means is we're setting f of x equal to g of x, because again, these are the y values. So y is equal to y, and then f of x is equal to negative 1/2 x minus 8, and g of x is equal to 2 times x minus 4, just like we did when solving a system of equations. Then we just solve, and then we have our x value that we're looking for. And then use that corresponding x value to find the necessary y value of the point. So we're going to distribute the 2. We get 2x minus 8. And then we need to simplify this equation. I'm going to add 8 to both sides of the equation, and it just so happens that the 8 cancels out. And also I'm going to add 1/2 x to both sides of the equation, and I get 5/2 x. So if I put this 8 on the other side, we get 0 over here, and if I put this negative 1/2 on the other side, we get 5/2 x. So you can see that x must be 0 in order for that equation to work. So now we need to go to the second part of the problem. The second part of the problem is to find the y value of the point of intersection. We found the x value of the point of intersection of the two graphs. In order to find the y value, we can just plug in the x value that we found into one of these functions. Doesn't matter which one. They're both going to give the same y value. So we have negative 1/2 times 0 minus 8 is equal to negative 8. So now the point of intersection is 0, negative 8. And that is the answer. So the point on the graphs where these two functions intersect is 0, negative 8. Okay, so let's try another one of those problems. This is the same type of problem. We're just setting f of x equal to h of x. We're setting the y values of these graphs equal to each other. And f of x is 4 times x plus 3 minus 7, and h of x is x over 5 plus 2. So now we just have to solve. We're going to use distribution on the left side of the equation. then we're going to simplify, so we have 4x plus 5 is equal to x over 5 plus 2. Then we're going to subtract x over 5 from both sides of the equation, and we get 19x over 5. And we're going to subtract 5 from both sides of the equation. And then we can multiply both sides by 5, and we get 19x is equal to negative 15. And let's see if we can come up with any more room. And I guess if you want, we can call this the first step of the problem. So in the first step, we find the x value of the point of intersection, which is negative 15 over 19. The second step of the problem is to find a y value. We can use f or g, it doesn't matter. But I'm going to plug in negative 15 over 19. So I got that from down here. That's the x value of the point of intersection. And I'm going to plug that into f. And we just have to simplify. So looks like we're going to get 42 over 19 if we add 3 to negative 15 over 19. And then 4 times 42 over 19, that's 168 over 19. Sorry, these numbers are kind of big. And if we subtract 7, we're going to get, looks like we're going to get 35 over 19. So that is the y value of the point of intersection. So let's write the coordinates of the point of intersection. So we have negative 15 over 19, comma 35 over 19. And I got that number from there and that number from there. So again, sorry, those numbers turned out to be kind of big. Now that was the second step. You don't have to write steps, but that was the second step of the problem. So let's write first step for the previous problem and second step. Okay, so you can take a picture of these problems, number 31, 32, and 33, and you can use number 34 to help you do number 35. So what we're doing is we're simply setting f of x equal to g of x and then solving for x. That's it. It's that simple. So try number 35. When you come back, we'll do it together. Okay, we're back. So we want f of x to be equal to g of x. And f of x is x plus 1 and g of x is 2x. Subtract x from each side, and we get x is equal to 1. So that was an easy one. You got that right. Excellent. Try number 36. When you come back, we'll do it together. Okay, we're back. So we want f of x to be equal to h of x. Now f of x is equal to 9 minus 3x. And h of x is negative 4 times x plus 1. So we need to distribute, use the distribution rule, and Then we're going to add 4x to both sides and subtract 9 from both sides, and we get x is equal to negative 13. So if you got that right, excellent. Now for number 37, you're going to have to use 34 to help you. So we're not just going to find the x value, we're going to find the corresponding output, because we're looking for the coordinates of the point where the graphs of these functions intersect. Try number 37. When you come back, we'll do it together. Okay, we're back. So we're going to set the y values of the graphs equal to each other, and then find the x values that will make that equivalency statement true. So f of x is negative 10x, and g of x is x plus 2 over 5. Subtract x from both sides, and we get negative 11x is equal to 2/5. And then we're going to divide both sides by negative 11. But be aware that it's probably simpler to think of it as multiplying both sides by negative 1 over 11. But you have to use parentheses when we do that. So it's easier to do it this way because now we're just multiplying fractions. You can do it however you want, but if you divide both sides by negative 11, you're going to have a complex fraction. You're going to have 2/5 over negative 11. That's okay, but then you have to deal with the complex fraction. So we get x is equal to negative 2 over 55. Okay, the problem is we have to find the y value. That was only step 1. We found the x value of the point of intersection, but now we need to find the y value. So we're now going to plug in the x value that we got in the first part of the problem into one of the functions. Now I keep plugging into f, but you can plug it into g. It doesn't really make any difference. So I'm going to plug that in. Looks like it's going to be easier to plug it in to f. And so we get positive 20 over 55. But that can be reduced to 4 over 11 if we divide both sides by 5. So I plugged in the x value to the function, and I got the y value that we need. And now the coordinates of the point of intersection are negative 2 over 55, that's the x value, and the y value is 4 over 11. So sorry that I gave you such weird numbers to have to work with. But don't be afraid of fractions. Okay, so I want you to try another problem like that. Attempt number 38. And when you come back, we'll do it together. Alright, we're back. So we just need to make f of x equal to h of x. F of x is x over 6 minus 3, and h of x is 5 times x minus 2 plus 10. So we can use distribution. We have 5x minus 10 plus 10. And the 10s cancel out. And we can subtract x over 6 from both sides of the equation, and we get 29x over 6. Let's find some more room. This is step 1, by the way, of this problem. So now we're going to multiply both sides by 6, and we get negative 18 is equal to 29x. And let's see if I can make some more room. Sorry, my computer's going kind of slow. So x is equal to negative 18 over 29. So if you got that right, good. So now we go to step 2 of the problem. You can plug that in to h, or you can plug it into f. I've been plugging it into f in order to find the corresponding y value. So we have negative 18 over 29. So that gives us a complex fraction. And there's a lot of different ways that you can simplify a complex fraction. But probably the way easiest for students to understand is to treat this fraction symbol like a division symbol. Remember, fraction symbols can be considered a division operation, so I just changed that to this. And when you divide fractions, you just change to multiplication and flip the divisor, and now we're just multiplying those two fractions. So we get negative 18 over whatever 29 times 6 is, and that's going to be 174. And now, unfortunately, we do have to combine these numbers. We could just use a mixed number if you wanted to avoid having to deal with those big numbers. You can just write it as a mixed number. Okay, now you may have written this in a different way if you decided to write as an improper fraction. If you wrote it as an improper fraction, you should get negative 540 over 174. So if you got that right, excellent. Now, I think we can reduce this actually. In fact, I know we can reduce it, so I'm going to divide both sides by 2. And we get 9 over 87. 9 over 87. And let's see, if we reduce with the other type of answer, then we're going to get 270 over 87, negative 270 over 87. So there's a lot of different variations of that. Okay, again, sorry about those big numbers. Alright, let's try a different type of problem here. Okay, so this is the same type of problem, except we don't have to find the coordinates of the intersection. We're just finding the x values that make f of x equal to g of x, and f of x is x squared plus 10x minus 9, and g of x is 2x squared minus x plus 1. So we just have to solve this equation. Now, this equation may not look familiar, but it's actually going to be a quadratic equation because we have a variable squared, we have a variable that's not squared, and we have a number that doesn't have a variable. So we need to simplify this equation by combining like terms. So I'm going to subtract x squared from both sides. So that's going to make this x squared disappear, and 2x squared minus 1x squared is x squared. Now the reason I put the x squared on the other side, or I subtracted the x squared, is because I want this term to be positive. I'm then going to subtract 10x from both sides. That makes this 10x disappear, and negative x minus 10x is negative 11x. I'm then going to put this 9 on the other side by adding 9 to both sides, and that'll make this 9 disappear, and 1 plus 9 is 10. Then there's nothing over here, so I just write 0. So now the quadratic equation is in standard form. So we're now ready to solve the equation. We're going to use factoring, and so x can be 10 or x can be 1. So those are the solutions. Okay, so I want you to try a problem like that. You can get a picture of this problem to help you. And go ahead and try number 40. When you come back, we'll do it together. Okay, we're back. So we want to find the x value, or in this case, the x values, plural, that make f of x equal to g of x. Or excuse me, equal to h of x. And so we're going to add 3x squared to both sides and subtract x from both sides and subtract 9 from both sides. And this time I put everything on the left side of the equation because I want this to be a positive x squared. So now we're going to factor. The quadratic equation is in standard form. What two numbers multiply to negative 14 and add up to negative 5? Well, that's going to be negative 7 and positive 2. So x is equal to 7 or x is equal to negative 2. So if you got that right, excellent. Okay, let's try another problem here. If f of x is equal to that expression and g of x is equal to that expression, find the coordinates of the points where the graphs of these functions intersect. So this is an example where there's actually going to be more than one point where they intersect. So you're going to have a parabola that looks like this. That might look like the graph of f. And then you're going to have the graph of negative x squared plus 5, which might look like this. You'll have 2 points where they're going to intersect. I don't know if that's exactly what the graphs would look like. They're definitely going to be parabolas, but there's going to be 2 points of intersection. So we want the y values to be equal to each other because that's going to give us the points of intersection. So f of x is 3x squared plus 8x, and g of x is negative x squared plus 5. And so now we have to combine everything, and this is a quadratic equation. So I'm going to add x squared to both sides. That makes this x squared disappear, and we get 4x squared. And I'm going to subtract 5x from both sides. So I'm doing a lot of work at once. Or in one step, I should say. So this is step 1 of the problem. We're finding the x values that these graphs intersect. So now we're going to factor, because we have our quadratic equation in standard form. I'm going to try 2x and 2x. 2 times 2 is 4. And I'm going to try negative 5 and positive 1. 1 times negative 5 is negative 5. But I don't know if this is the proper factorization, so we have to check. So f of FOIL is 4x squared, O of FOIL is negative 10x, I of FOIL is 2x, and L of FOIL is negative 5. Combine these and we get negative 8x. Well, we got the right number, we just got the wrong sign, so we just have to change the sign. So I'm going to change that first sign to a negative and the second sign to a positive. So now we have the x values where the two graphs intersect. But that's just the first step. We need to find the corresponding y values where the graphs intersect. So I'm going to plug in x to g this time. It doesn't matter which function we plug it into. You get the same answer. I'm going to use g because g is a simpler function. So I'm going to plug in 1/2 and I get negative 1/2 squared plus 5, and that becomes negative 1/4 plus 5. Remember, we're squaring the 1/2. We're not squaring the negative symbol in front of it. That green negative symbol is not part of the exponent. So then we add those together and we get 4 and 3/4 if you want to write it as a mixed number. So what this means is that one of the points where the graphs intersects is 1/2, 4 and 3/4. So there you go. But we have to find another point where they intersect. So we have to plug in negative 5/2 that we got from the other x value. So let's do the math. We have a negative 5/2 squared plus 5, and that's going to be negative 25 over 4, and that is equal to negative 5 over 4. Okay, so I want you to try a problem like that. Take a picture of number 41. There's going to be 2 points, so you need the coordinates of 2 points. Try 42. When you come back, we'll do it together. Okay, we're back. So we want f of x to be equal to h of x as usual, and that means that 2x squared is going to be equal to negative 3x plus 2. That's a quadratic equation, so we have to put everything on one side. And you want it to be on the left side because you want this coefficient here to be positive if you can. And we're now going to factor. So 2 times 1 is 2, and I'm going to say negative 1 times positive 2 is negative 2. Then we have to check this factorization. F of FOIL is 2x squared. Multiply the outside terms, you get 4x. The inside terms, you get x. Negative x, that is. And then last terms, you get negative 2. So 4x minus x is 3x. So it looks like that worked. So we have two x values, two points of intersection. So x is 1/2 and x is negative 2. So now we go on to the second part of the problem. Now that we have the x values where the graphs intersect, we can find the corresponding y values. So I'm going to use f this time. I'm going to plug in the x value to the function f, and we get 2 times 1/4, which is 1/2. So the corresponding point is 1/2, comma 1/2. Okay, and then I'm going to look for another point. I'm going to plug in the other point that I got from here, or the other x value, that is, not the other point, the other x value. And I'm going to plug it into the same function, and we get 2 times 4, which is 8. So we have another point of intersection between those two functions, negative 2 and 8. So if you got that right, excellent. So there's 2 points where the graphs intersect. We have a parabola and then we have a line, and these 2 points are where they intersect. Okay, so let's do number 43. So if f of x is equal to that expression and h of x is equal to a constant negative 9, for what values of x does f of x equal h of x? So sometimes a function can be equal to a constant. That just means that if you graph it, it's a straight line. So this is the same type of problem. We just want f of x to be equal to h of x. F of x is negative 2 times 3x plus 1 squared minus 3, and h of x is equal to negative 9. So we need to find the x value that will make this equation true, because that'll make the functions equal to each other, or at least the outputs equal to each other. So now we're going to add 3 to both sides of the equation. And divide both sides by 2. Now we're going to square root both sides of the equation. And remember, we must write a plus or minus symbol. The most common mistake that students make is they don't write a plus or minus symbol when we square root both sides of an equation. Then we're going to divide both sides by 3. And we're done. So I want you to try a problem like that. Go ahead and try number 44. When you come back, we'll do it together. Alright, we're back. So we want h of x to be equal to g of x. H of x is 5, and g of x is x minus 2 squared over 4 plus 2. So in order for h of x to be equal to g of x, we have to find an x value that will make that true. So we just have to isolate the square. I'm going to subtract 2 from both sides. And then I'm going to multiply both sides by 4. And then I'm going to square root both sides, and I have to write a plus or minus symbol when I do that. Whoops, that should be x minus 2. Now there's a perfect square inside there, so I'm going to have to factor that to 4 times 3. And that becomes the square root of 4 times the square root of 3. You don't have to show this math. The square root of 4 is 2. That's just basic math that we learned in my beginning algebra course and my intermediate algebra course. Then we're going to add 2 to both sides of the equation. And I probably should space this out a little bit more. At that point, we're done. Okay, so if you got that right, excellent. There's 2 x values that make that true. So we have 2 more problems. If g of x is equal to that expression there, and f of x is equal to 4, find the coordinates of the point where the graph of these functions intersect. So if we're looking for the point where they intersect, then we have to set the y values of the graph equal to each other. Again, g of x and f of x represent the y values of the graph. We could set the x values equal to each other because the x values are equal at the point of intersection also, but x is not solved for in these equations, so we have to use the y values. G of x is 2 plus the square root of x over 2 plus 2 all over 3, and f of x is 4. So now all we have to do is isolate the square root symbol. So we're going to subtract 2 from both sides of the equation. Now we're going to multiply both sides of the equation by 3. Then we're going to square both sides of the equation. Then we're going to subtract 2 from both sides of the equation. And then we're going to multiply both sides of the equation by 2. So that's the first part of the problem. That's step 1. Step 2 is to find the coordinates of the point. Now notice we only got one x value, so that means that there's only one point where these two functions intersect. So now we have to plug in 68 into one of these functions to figure out what the y value would be. But if I use this function up here, it's going to make things a lot easier for us. If I plug in 68 to that second function, f, I'm going to get 4, because it doesn't matter what you plug in to x, you're going to get 4 no matter what. So that means that the y value has to be 4. So if you graph f of x equals 4, it might look like that, and then your other graph might look something like this. So because this graph is a horizontal line at y equals 4, you know the y value of the point that we're looking for has to be 4. So there's not much work when it comes to that. So the point that we're looking for is 64 or 68 comma 4. Okay, so why don't you try number 46. When you come back, we'll do it together. Alright, we're back. So step 1 is to set h of x equal to f of x. So the square root of negative 5x plus 2 minus 7 is equal to negative 6. Now we just have to solve the equation and isolate the square root. So I'm going to add 7 to both sides. Then I'm going to square both sides of the equation. 1 times 1 is 1. Then I'm going to subtract 2 from both sides of the equation. And we get negative 5x is equal to negative 1. I'm going to divide both sides by negative 5, and we get 1/5. So we found the x value of the point of intersection. Now, again, because we have a constant function here, it means that the y value has to be negative 6. I mean, there's no other option. So if you plug in 1/5 to that function, we're going to get negative 6. That's the easiest way to do it. We could plug in 1/5 to this function and we get negative 6 also, but we can see that that has to be the y value of the point of intersection, because f of x is always equal to negative 6. So the point we're looking for is 1/5 negative 6. So if you got that right, good job. So that was the class today. If you'd like to take screenshots of all the work that we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1 and number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, and number 11. But don't go before you get your homework. Remember, the homework is not optional. Here's screenshot number 1 of the homework, and screenshot number 2, and number 3, number 4, number 5. So that is the homework, but don't go before you get the answers. Here's the answers to the homework. It's not enough just to attempt the homework. It must be done correctly and completely and neatly, and keep it in order in your binder. So get that homework done, and I'll look forward to seeing you in the next class.